And I have been introducing you to the hypothesis testing and related frameworks. And here is another important intuition you have to have. So now we are comparing two models, restricted model and unrestricted model. The restricted model is nested by the unrestricted model. So we are comparing two models and one has strictly more assumptions, restricted model has more assumptions than the other. Then when we compare these two, we usually compare them as efficiency versus robustness. So let's first think about this. When you use more assumptions, like the restricted model uses more assumptions because it uses all the assumptions in the unrestricted model plus the hypothesis. Then which is better? Now we are considering which one is better, unrestricted model or restricted model. It depends on whether your hypothesis is correct or not. Suppose that if your hypothesis is correct, then the restricted model is better because it uses more assumptions, so it will be more efficient and it utilizes more information. So more information makes the estimator more efficient. So restricted model is good. However, the problem here is if the hypothesis was wrong, then the restricted model is wrong. If any of the assumptions is wrong, then the model is wrong. So the restricted model becomes wrong, and so then you have to use the unrestricted model. So this is called robustness because the unrestricted model is robust, stronger, and it survives even if the hypothesis is wrong. So it uses a fewer number of assumptions, so even if it is less vulnerable to potentially wrong assumptions because it utilizes fewer assumptions. So their comparison here is exactly, this is what I explained. If the hypothesis is correct, restricted model is more efficient because more assumptions, more information, more efficiency, or more accuracy. And otherwise, but on the other hand, unrestricted model is robust. So robust means this model is more likely to be correct, because for a model to be correct, all assumptions must be true, but restricted model utilizes more assumptions, so it's more vulnerable to potentially to failure of one of those assumptions. So U is more robust. So the robustness, and you must be familiar with efficiency now, but you are going to hear a lot about robustness. So many empirical studies consider robustness check. That means you must. So if you have a result, estimation result, then what you should worry about is for the estimation result, you must have used many assumptions. Now you need to worry about if those assumptions are correct or not. If any of the assumptions is wrong, then your result is wrong. So you are changing the assumptions and see how your result changes. So ideally, your result should not change even if you change some model assumptions. So for example, changing the variables or changing functional forms or changing the sample, or considering potentially ruling out or worrying about the outliers or blah blah blah. So by changing the assumptions and the models, you verify your model is robust and your model is not wrong. There is no problem. So and another related concept is specification test. Specification test is a kind of hypothesis test, but it is slightly different from typical hypothesis test, because as previously I said, for a model to be correct, all of its assumptions must be correct. And a specification test is to see whether a model is correctly specified or not. So basically, it is testing whether all the assumptions are correct or some of the assumptions are wrong. But I don't know which is wrong. It does not say what is wrong, but it is testing. Like, so if you are using 10 assumptions, you just want to see whether all of them are correct or at least one of them is wrong. So in some specification test, you know that the model is wrong, but you may not know which assumption is the problem. So it's a little bit subtle difference. And we are not going to consider here later. Maybe we have a chance to talk about specification test in the instrumental variable regression case. So we are going to discuss this. So far I just gave you many new concepts. Maybe you have not heard about them, but I think they are related to each other and very important concepts in econometrics, and it must be helpful at some point when you think about your model and when you think about assumptions and hypothesis testing in your dissertation. So I explained them. So let me summarize again. So we consider hypothesis testing is what we are doing, but you may understand hypothesis as another assumption. So for a hypothesis to be tested, for a hypothesis to be testable, your model must be identified without the hypothesis. So your hypothesis will become an over-identification condition. And second, and then I talked about the nested relationship. When you have more assumptions, we say that model is nested to the model which is more general, which is more like a milder. And then I connected the nesting relationship to comparison between efficiency and robustness. So robustness is also very important in your empirical work. So think about this problem. And finally, specification test is another type of hypothesis test, but it does not specify what is the restricted model, what is the unrestricted model. So you need to think about all the assumptions. Then there is no unrestricted model in this case. Anyway, okay, this is it. And in the next video, I will talk a little bit about statistics. Let me do it now. I think I can do it. So we are going to use quadratic form and chi-square distribution. I will introduce you the chi-square distribution. So t-test, let me start from the t-statistic. T-test is used for a single hypothesis about one parameter. And you may remember this. T-test is your estimator minus hypothesis value divided by standard error. So not a problem. Square root n is actually in the standard error. And you must know this well. So this is not my interest. I'm not talking about the t-statistic itself. But when you have more than one parameters involved in more than one inequalities involved in the hypothesis, you cannot use the t-test if you want to test them jointly. And then we are going to use this type of quadratic form. F statistic is written as, so suppose that you are testing beta 1 equals to 1, beta 2 equals to 2. And then you may have two t-test statistics, but they are separate. And also you have to consider their covariance. So in the end, you are going to use this formula. So this is the difference between beta 1 and 1, beta 2 and 2, and the difference is weighted by variance inverse. This is exactly the same form as the GMM criterion function, right? Remember, GMM uses variance inverse. Yes, it is. V is the asymptotic variance. So variance inverse is multiplied, and this is the conditions you expect to be true. So if you think this is close to zero under this hypothesis, so this is the exactly the same structure of the GMM distance. So everything is like most of the maybe all the tests can be formulated in that way. I'm going to use this form. This is F statistic, and we call this quadratic form. And usually Q is it convert, and later if you multiply n, and then so the reason why we multiply n is because square root n should be multiplied here, square root n must be multiplied here. So because there are two square root of n's, we have n, and it converges to a chi-square distribution with parameter q. Q is the degrees of freedom, which is the number of restrictions. Like in this case, there are two restrictions, so Q will be 2. So this is just very basic statistics distribution theory you need to know. Okay, I will be considering this later. Maybe I think somehow I repeated the same thing again. So thank you. See you later.